All right, let's talk about mapping the unmappable. We're about to dive into one of the coolest tools in data science, something that helps us cut right through the complexity and find that hidden story that's always lurking in our data. I'm talking about principal component analysis, or as you'll usually hear it, PCA.
Have you ever opened up a spreadsheet, right? And you're just staring at hundreds, maybe thousands of columns, and you just feel completely and utterly lost. It's like you've been dropped in the middle of this huge, dense digital forest. You know there's a story in there somewhere. You can feel it, but you can't see it because there are just too many trees in the way. So, the big question is, how do you find that bigger picture?
Well, what if I told you there's a map? A tool that can lift you up out of the weeds and give you this incredible bird's-eye view of the entire landscape. Yep, you guessed it. That map is PCA. And it was literally designed for this exact problem, to help us finally see the forest for the trees.
Okay, so let's start right there, in this data forest. What exactly makes it so hard to get around? Well, this challenge actually has a name, and trust me, it's a big deal in the world of data science. The problem, at its core, is something called high-dimensional data. And that's just a fancy way of saying data with tons of features, dozens, hundreds, sometimes thousands of columns. And this leads to this infamous problem called the curse of dimensionality. Okay, think about it like this. If you want to describe a person, height and weight are pretty easy, right? But what if you add eye color, and shoe size, and their favorite food, and then 100 other things? All of a sudden, finding two people who are similar becomes nearly impossible. The data just gets spread so thin, our computer's slow to a crawl, and trying to visualize it, forget about it. There's no way you can plot 50 different dimensions on a single chart.
So how in the world do we escape this curse? Well, this is where the hero of our story comes in. Let's talk about PCA and its mission to find the perfect angle.
So what is PCA, really? At its heart, it's a super smart simplification technique. It takes all of your original, kind of messy variables, and, well, it combines them in this really clever way to create a smaller set of brand new features. We call these principal components. And these new components, they capture the absolute essence of your original data. It's all about cutting through the noise to find the real signal. And this right here is the most important part, so listen up. PCA is not about deleting data. It is all about changing your perspective. It's about finding a better, clearer way to look at the information you already have.
Here's a great way to think about it. Imagine your data is a really complex, beautiful sculpture. Now, if you wanted to take the best possible photo of it, you wouldn't just snap a picture from wherever you happen to be standing, would you? No way. You'd walk around it, you'd look for that perfect angle.
You're looking for that one sweet spot, that one angle that reveals the most structure, the most character, the most story. Well, PCA does exactly that, but for our data. It mathematically rotates the entire dataset to find the one view that just makes those hidden patterns pop right out at you. But how? How does it actually do that? Okay, let's peek under the hood for a second. Don't worry, no crazy math, and see how PCA actually finds the main story. It's basically a three-step dance. First, PCA scans your data and identifies the directions where there's the most spread, or what we call variance. Think of it as finding where the data is most stretched out. Why? Because that's where the most interesting stuff is happening. Step 2, it rotates the entire data set to line up perfectly with these new high-spread directions. And then step 3, the magic part. It lets you keep just the first few of these new components. And the thing is, those first few now tell most of the story, so you can compress the rest without losing the main plot. And this is really the core philosophy behind PCA. It works on one big assumption. Variance equals information. And it makes sense, right? If all your data points were just in one tiny, tight clump, what's the story? Not much. But the more spread out they are, the more they tell you about all the differences and patterns in your data set. So PCA is all about finding that spread and maximizing it. So these new directions with all the spread, those are our principal components. The very first one, which we call PC1, that's the big one. It represents the big picture trend. It's the single direction that captures the most possible variation in the data. Then you have PC2, which finds the next biggest trend. But here's the cool part. It's totally independent of the first one. And what's really amazing is that a lot of the time, just these first two components are enough to give you a surprisingly clear map of your data.
Okay, this is all powerful stuff in theory, but where do we actually see this in the real world? Let's go take a look at PCA out in the wild.
Oh, its applications they're everywhere, seriously. It's the secret sauce behind image compression, You know, how you can shrink these huge photo files down without really losing quality? It's how we can visualize ridiculously complex data by squashing it down onto a 2D chart where suddenly we can actually see clusters and patterns. It totally supercharges machine learning models by giving them only the most important features to work with. And in massive fields like genetics and finance, it's what helps researchers find those crucial hidden drivers among thousands and thousands of variables.
So, as we start to wrap this up, what's the one thing you should walk away with? If you remember nothing else, remember this. PCA is all about finding the clearest view.
Now, a quick heads up. PCA isn't a magic wand for every single problem. It does have a couple of quirks. For one, it assumes the patterns in your data are linear. Straight lines. So it's amazing for that, but it can sometimes miss more complex, curvy relationships. And the new components it makes are these mathematical cocktails of your original features, which means sometimes they can be a little abstract and a bit tricky to explain in simple terms.
But please never forget the big idea here. PCA is not about throwing away data or losing information. It is about finding a better lens to see it all through. It's not about deleting the details. It's about revealing the main headline that was buried deep in all that noise. And that's a really powerful mental shift, isn't it? Simplicity doesn't have to mean loss. Sometimes, it's the ultimate form of clarity.
When you learn how to find that most informative angle, you gain this incredible power to turn overwhelming complexity into a clear, actionable picture. PCA, it gives you the map. So the only question left is, what complex forest are you going to map out first? Thanks for joining me on this explainer.